Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 3, the Unit Circle and Circular Functions, Video 7, Using Inverse Trig Functions Outside of Quadrant 1. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we briefly looked at the ranges of three inverse trig functions, cosine, sine, and tangent. In this video, we learn how to use inverse trig functions to locate arcs or angles outside of quadrant 1. Recall the domains and ranges of cosine, sine, and tangent. Inverse cosine or cosine inverse has a range between 0 and pi. Sine inverse and tangent inverse both have ranges between negative pi over 2 and pi over 2, whereas the range of tangent inverse excludes those values because they make tangent undefined. To use these ranges and a calculator to find values of S in quadrants outside the ranges of these inverse trig functions, so outside of these ranges, we use a concept similar to reference angles called reference arcs. For example, find the value of S in the interval pi over 2 to pi such that sine of S is equal to 0.75. Now, if you're thinking we'll just hit it with the sine inverse, you're partially correct, but the interval in which we're looking, pi over 2 to pi, is not included in the range of sine inverse. The range of sine inverse ends at pi over 2. We're looking for a value in an interval that begins in pi over 2. So just doing sine inverse will not be sufficient. But we'll do that to start. Using a calculator in radian mode, we evaluate sine inverse of 0.75 to get approximately 0.8481. You can check that. However, because of the range of inverse sine, we can only get values between negative pi over 2 and pi over 2. Now, if you check, 0.8481 is in this interval, but it's not in this one up here. Pi over 2 is about 1.57. So 0.8481 is less than pi over 2, so it's not in the interval we're looking for. So how do we get it? Well, like a lot of trig problems, we sketch a picture of what we know and what we want. So here's a picture with a black arc and a green arc. The black arc represents the angle we're looking for in quadrant 2, or rather, I should say the arc we are looking for in quadrant 2. Since the arc we're looking for is between pi over 2 and pi in degrees between 90 and 180. And remember, in circular trig, sine of an angle is equal to the y-coordinate. And so since we know sine of S is equal to 0.75, the point we're looking for has a y-coordinate of 0.75 with an unknown x-coordinate for now. Now, the green arc over here represents the value given by the calculator. Sine inverse of 0.75 equals an arc length of 0.8481. And this is because the range of sine inverse, negative pi over 2 to pi over 2, includes quadrant 1. Sine inverse can only give me answers over here. I'm looking for an answer over here. So how do we take this picture and get what we want over here? Well, the same way we've done with reference angles before. Just like before, we use the arc in quadrant 1, this green one, as a reference arc in quadrant 2. So we're going to move this arc over here into quadrant 2. Now, it's the same arc length, okay? But how are the desired black arc that we're looking for and the green reference arc related? Well, just like before in quadrant 2, together, what we want and what we know make a semicircle. Now, we're in radians, so a semicircle is pi. As such, the sum of their arc lengths equals the semicircular arc length on the unit circle, which again has a total length of pi. So the black plus the green is equal to pi. Thus, the desired black arc length is pi minus 0.8481, or approximately 2.2935. And we could check that answer. We could check it by making sure it's in the requested interval and by checking sine of S. Since pi over 2 is about 1.5708, and pi is approximately 3.1416, and this number is between them, we see that S is in that interval. And using a calculator, sine of that S, 0.8481, to 4 decimal places is approximately 0.7500. So we just do like we normally do with angles, we just do it with arcs. And remember, we're in radians, so proceed cautiously. Now you try. Pause the video and try the following. Find the value of S such that cosine of S is equal to negative 0.4. And S is an element of the interval pi to 3 pi over 2. And just as a reminder, the range of cosine inverse is between 0 and pi, and we are looking for an angle between pi and 3 pi over 2. So pause the video, give it a try. All right, here's your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. I'm going to briefly discuss it. First, we do cosine inverse of negative 0.4 and get about 1.9823. Now that is in quadrant 2 because it's greater than pi over 2 but less than pi. The desired answer lies in quadrant 3. So what we basically do, and I'll sketch a real small picture here because I don't have a whole lot of room. What we basically do is we draw the arc over here in quadrant 2 that we got, which was the 1.9823. What we're looking for is over here. So we need the reference angle. We need the reference angle. We need the reference angle. And so this reference angle would be pi minus, where's my dot? There it is. Would be pi minus that, which is about 1.1593, or rather, I should say reference arc. So that's the size of that arc there. But we want to measure it over here in quadrant 3. So we would take a semicircle plus that arc. Semicircle is pi plus the arc is about 4.3009. You could check that this is in the desired interval and satisfies cosine of s is equal to negative 0.4.